Okay, hey guys, just thought to make a quick video on distance time graph. As you can see, we've got two situations here, a top guy and a bottom guy. As he's moving across from the tree towards the house, his distance time graph is plotted below. All right, you can see for the first one, in fact, for both of them, they both start off with a flat line. You see over here, it's a flat line. It means as time passes, the distance is still the same. So that's why it's not moving. So as he moves, then the line will actually start to curve up, move up with a positive gradient. Okay, you can see not moving and starts to move. The one at the bottom, it moves faster, then slower, right? So you can see there's actually a change in gradient, whereas the one on top is also changing gradient. But what's happening here? You see, it's not moving here, the line. Then after that, what happens? It moves a little bit and boom, it moves much faster. So you can see that the gradient actually changes. So what's the first thing that we learn in distance time graph? First thing is that distance time graph, other than giving you the distance and the time, the gradient also gives you the speed. Okay, so okay, bear that in mind. So that's important for distance time graph. Okay, so in other words, over here, for the top one, if I have a less steeper gradient, it means it is slower, and a steeper gradient, it means it is faster. That's right. So the bottom one will be faster, followed by slower, because it's steeper gradient and a less deep gradient, a more gentle gradient. What about the one that's a horizontal flat line? So the horizontal flat line will basically mean it is not moving. Okay. All right. Okay. So what do you mean by gradient? Okay. So if I would just to give you the analogy of our good friend here, Ant-Man. That's right. Okay. Ant-Man. And what do we give him? We give him a task. Okay. Oh, what task is this? Basically, okay, Ant-Man, let's climb the hill. Okay. So if we were to have the hills, okay, as the hill changes as he climbs, you can see from the left to the right which one is the steepest. The steepest all the way to the right, and the most gentle one all the way to the left. So what can you say about the gradient or the steepness of the slope? You're right. It's increasing. In other words, increasing gradient. And the one at the bottom, you can see the gradient becomes more and more gentle. So it is a decreasing gradient. Okay, so where am I coming with this? Okay, we are coming basically, if you were to look at the distance time graph, okay, so of any object that's in motion, you can see the one on the left, on the top two, body at rest and body at uniform speed. You can see here the gradient doesn't change at all. What about the one on the right? Ah, the one on the right here, you can see the gradient is also the same. What do you mean? If I were the Ant-Man here, here, and here, the Ant-Man will feel, he will just say, hey, all the gradient is the same. So same steepness. In other words, the distance time graph, we established before that the gradient represents the speed. Okay, so the bottom two is the same. You can see the one on the left at the bottom, the gradient is, you are right. Since the gradient is increasing, what we can say is the speed is also increasing. And the one on the right here, the bottom right corner, since the gradient is decreasing, we can say it is, you are absolutely right, decreasing speed. Okay, so just one point to note, as you can see, distance time graph never goes down. In other words, you always will, wherever you travel, even you move backwards or forwards, your distance will always increase. You will never get negative grade distance or less distance. Okay, all right. So so just to recap, okay, so in distance time graph, we give you the distance and time. Okay, that's it.